All right, let's jump into some of the latest AI image generation research.
Sounds good.
You sent over a paper with a pretty interesting title.
Mm-hmm.
How many Van Goghs does it take to Van Gogh? Finding the imitation threshold.
Yeah,
I mean,
a good one.
who wouldn't want to dive into that?
Definitely grabs your attention. And it really gets at this core question in AI image generation.
Okay.
How much exposure to a specific concept does an AI need before it can start making believable copies of it?
So for our listener who's maybe familiar with AI and image generation, but isn't super deep into the research side of things, can you set the stage? What is the problem this paper is trying to address?
Yeah, so this paper dives into what they call finding the imitation threshold, or FIT.
Oh.
And what that boils down to is trying to figure out how many times an AI model needs to see something in its training data before it can convincingly make a copy of it. So, we're talking about specific people, art styles, you name it.
So if I'm understanding this right, there's this potential for danger where an AI could get a little too good at mimicking the stuff that it's seen.
Yeah.
And that's where things get kind of legally and ethically complicated.
Exactly. Yeah, we're talking about potential copyright issues, privacy violations, things that we need to really get a handle on.
Yeah, for sure.
Yeah.
So getting back into the research a bit more, they were trying to find this imitation threshold, but there was a big challenge right out of the gate.
Yeah, the ideal approach to this would be to train a bunch of different AI models.
Okay.
Each with different numbers of training images for each concept. And just see, okay, when does it start to really nail these imitations?
Yeah.
The problem is training a large AI model is crazy expensive.
Yeah.
They mentioned Stable Diffusion in this paper, which is a pretty popular AI image generation model that costs about $600,000 to train from scratch.
Oh, wow.
So
that's not exactly a practical approach.
You know, not really scalable, right? Yeah. So you need a more clever solution.
Yeah. So what'd they come up with?
They came up with Mimetic 2.
Mimetic 2?
It's a bit of a mouthful.
Yeah.
Stands for Measuring Imitation Threshold Through Instance Count and Comparison.
Gotcha.
So instead of training hundreds of models from scratch, they thought, okay, how can we leverage these pre-trained models and analyze them in a clever way to get at what we want?
Okay, so break it down for us.
Okay.
How does Mimetic 2 actually work?
So the first thing they did is they selected a bunch of different concepts to test.
Okay.
This could be faces of famous people, art styles, different types of objects, things like that.
Yeah.
And they made sure that these concepts appeared in the AI training data with different frequencies.
So like some faces might show up 1,000 times and some only a handful.
Exactly.
Gotcha.
And then they also used multiple different versions of Stable Diffusion that had been trained on slightly different data sets.
Right.
So this is a nice way to compare results across models.
Gotcha.
So once they've got these concepts and they've got these different models trained, they then generate a ton of images from each concept using each of these different models. And they do this by using carefully designed prompts, like text instructions that you feed to the AI to tell it what to generate.
Yeah.
And this is important because they want the thing they're trying to test to be front and center in the image.
Yeah.
So for example, if they're trying to see how well the model can generate a specific person's face, they might design a prompt that says something like a photorealistic portrait of so-and-so or something like that.
Makes sense.
So now that they've generated all these AI images, the next step is to compare those generated images to the original training data to see how similar they are.
So they're measuring how much the AI is imitating the original concept. And I imagine that comparing these images can be a little tricky, right?
Right.
There's a lot of variation of, a person's face can change over time. An artist's style can change over time.
Absolutely.
But how do they account for that?
So instead of comparing every generated image to every image in the training data set, they focused on the 10 most similar images for each concept.
Interesting.
And so this lets them really zero in on, is the model just picking up on one specific feature, or is it learning the concept more broadly?
Right. So they've generated the images, they've compared them, and they've got all this data now about how similar the images are. What do they do with it?
So to actually pinpoint that imitation threshold, they use something called a change point detection algorithm. And so what this algorithm does is it looks for a point in the data where the similarity scores suddenly jump up. as the number of training images increases.
Interesting.
And so that point is considered the imitation threshold.
Right. So essentially they're looking for that point where the AI goes from like, okay, this is just random noise, to, wow, this actually looks like the thing.
Exactly.
Gotcha.
And so what did they find? Well,
yeah, what'd they find?
They found that this threshold actually fell between 200 and 600 images for most of the concepts.
Oh, wow. So it's a pretty specific range.
Yeah, it was surprisingly consistent.
So if I'm understanding that right, if a concept appears less than 200 times in the training data, the AI is probably not going to be able to convincingly replicate it.
That seems to be the general trend, yeah.
Interesting.
But, it's not a hard and fast rule.
Okay.
And that's exactly what we'll get into next.
Right.
The outliers. The weird cases where things didn't quite behave the way we expected.
This is already blowing my mind, and we're just getting started. Let's take a quick pause so our listener can process this amazing research.
Sounds good.
And we'll be right back to continue this deep dive in a flash.
Great. Welcome back.
So let's dive into those outliers that you mentioned before the break.
Right.
The cases where things got a little unexpected with the AI.
Yeah, those were some really fascinating cases.
Okay.
The cases where the AI was able to generate something very convincing, even though the concept it was imitating only had a few examples in the training data.
So essentially, it was able to learn faster than expected.
Exactly. Yeah, it suggests there's some scenarios where AI can be super efficient at picking out important features and learning from limited data.
So it seems like it's not just about the amount of data,
right,
but also how efficiently the AI can actually learn from it.
Exactly. And that opens up a lot of really interesting possibilities.
I can imagine. So what are some of the factors they thought might contribute to this really efficient learning?
Well, they speculate that the quality and diversity of the training images play a huge role.
Okay.
So if you give the AI high-resolution images that clearly represent the concept and capture its variations, it might be able to learn a lot more from even a small number of examples.
So it's like giving it a crash course, but with the best possible learning materials.
Exactly. Instead of overwhelming it with a ton of mediocre data.
Yeah.
You give it a small, carefully curated set of really good examples.
Really interesting.
And it suggests that sometimes less can actually be more, as long as that less is really high quality and chosen strategically.
That's a cool concept.
Yeah, and it really makes you think about the nature of learning itself. Could it be that AI in some cases actually learns more efficiently than we do?
That is wild.
Yeah, it's a pretty mind-boggling question and one that a lot of researchers are trying to answer.
That's super interesting. So we talked about the amount of data. We've talked about the quality of the data.
Right.
Are there any other factors that they found that might influence this imitation threshold?
Yeah, they mentioned a few other things, like the specific architecture of the AI model.
Okay.
The order the data is presented.
Right.
And even the math equations used to optimize the learning process.
So even little tiny things can affect the outcome.
Exactly. Yeah, it's like baking a cake. Even if you use all the same ingredients, slight changes in the oven temperature or the mixing time can change how the cake turns out.
Makes sense.
And that really highlights the complexity of AI systems.
Yeah.
Even with all the research that's being done, there's still a degree of unpredictability in how these things behave.
Yeah, that unpredictability makes it really important to continue doing this research.
Absolutely.
To try to figure out how we can control and anticipate AI's behavior.
Right.
Especially given all the legal and ethical implications we talked about earlier.
Exactly. The more we understand about how these models work, the better we can use them responsibly.
Okay, so before we wrap up, I'm kind of curious about something you mentioned earlier.
Okay.
About those cases where the AI actually performed better than expected, even with limited data.
Right.
What was going on there?
Yeah, those cases provide some really interesting insights into the potential of AI.
Yeah.
Should we dive into those next?
Let's do it. I'm excited to hear what other surprises this research has in store.
Yeah.
Okay, so let's dive into those cases where the AI kind of exceeded expectations.
Yeah, these were really fascinating instances where the AI was able to achieve really high imitation scores. Even when the concept it was imitating only had a handful of examples in the training data.
So, like, it was able to learn a lot faster than expected.
Exactly. Yeah, it really suggests that under the right conditions, AI can be super efficient at, picking out the core elements of a concept and learning from limited data, which is really cool when you think about the possibilities there.
I can imagine. So what factors did the researchers think might contribute to this super efficient learning?
Well, they speculate that the quality and diversity of the training images are really crucial.
Okay.
So if the AI is being fed these high-resolution images that very clearly show the concept and capture its variations, it might be able to learn a lot more, even from a small sample size.
So it's like giving it a crash course with, like, the best possible study guide.
Exactly. Yeah, instead of overwhelming it with a ton of mediocre data, you give it this carefully curated set of really high-quality examples.
It's like the difference between, like, cramming for a test versus really understanding the material.
Exactly. And it suggests that less can actually be more, as long as that less is really well chosen.
That's a fascinating idea. It really challenges our assumptions about how learning works.
It does, yeah. It makes you wonder, could AI in some cases be even more efficient at learning than we are?
It's wild to think about.
It is, yeah. It's a pretty mind-blowing idea.
I think it's time to wrap up this deep dive. What are some key takeaways for our listener to keep in mind?
I think one of the biggest takeaways is this idea of the imitation threshold.
Okay.
This point where AI can start making really believable copies of what it's seen and understanding what influences that threshold, the amount of data, the quality of the data, how well the images match up with their captions. All of these things are crucial for making sure we're using AI in a responsible way.
Yeah, I think that's super important, especially with AI becoming more and more a part of our lives.
Absolutely.
Well, this deep dive has been super insightful. Thanks so much for guiding us through this research.
It's my pleasure. I always love diving into this stuff.
And to our listeners, thanks for joining us.
Yeah, thanks for listening.
We hope you found this as thought-provoking as we did. And until next time, keep those questions coming and keep exploring the world of AI.